Hi, this is Nathaniel Rogers for cybersecurity class for Professor Wang. In this video, I'm going to be showing my design for a cybersecurity lab, both virtual and physical, and hopes that some of these ideas can be implemented. But the first thing I'd like to talk about would be the attributes of the design itself and what the cybersecurity lab should be. And it should be stuff like reconfigurable or adaptable, which is basically meaning that you're allowed or you have the ability to change operating systems and different variables to be able to test different environments and to test different cybersecurity tools. Another one would be, it has to be heterogeneous, which is basically meaning the lab is comprised of multiple different platforms from multiple vendors, so you have a more real-world situation on getting through the tools and making sure that you're using each one of these tools on something that you will find in the real world or need to protect against in the real world. Another attribute that I thought was important was the scalability, which would be the lab should be able to sustain as many students as possible, but with allowing each student to have each individual task, so no student is left behind doing nothing while no student is overworked. Of course, it has to be cost effective. The cost of the setup and maintenance of the lab should never be more than what's being simulated in the lab, which means what you're putting into this lab, physically, virtually, all these things, they need to cost less than the activities you're going to do, and that factors in experience, educational purposes with that, a lot of different things that go along with that. The lab should be robust, which would make it so it could sustain and handle inadvertent or accidental damage by the students, and then quickly recover from that damage to carry on the lab practices. The lab should of course be maintainable, easy to maintain, make sure it's good. It has to be realistic. It needs to provide a practical and a first-hand experience to the students to allow for real-world issues. You can't be using things that you're not going to find in the real world, or outdated technology, or technology that's probably even too new to be able to start working on. It needs to be realistic so we can have the most educational time in this lab. And it also needs to be insulated, and that's probably the most important part, is that the lab activities should not affect the SUNY Canton network itself. So the physical lab design, disregarding the computers, the clients and stuff, you need the desks, like maybe a workstation where multiple people can work at once on the same project, with another area designated for maybe individual lab practices. Having a asset or a secure systems experimentation testbed, which is an area that would allow for experimenting with things like maybe phones that aren't too feasible to be using with multiple people, or things that are harder to come by or more unique. It also should probably have a own section for the servers, the cluster of the servers, so no one's getting in the way of that and stuff and whatnot. That's all really important. So the next part that is going to be more extensive is the rundown on how the physical network should be set up. So to begin, I would start off with the gateway. And the gateway is a firewall, a router, a DHCP, a DNS server, all in one, that protects the SUNY Canton campus network from the lab activities. It also creates a isolated environment where people in the lab can connect to that network, so they can be allowed to do things and test these variables and have a privately run network where really only the restrictions are the policies of that lab. The next thing that comes after the gateway would be the switch. And what the switch allows for is it allows for all the computers on all the computers in the lab to be networked together by using packet switching to receive, process, and forward data to the destination device, the gateway. A switch I was thinking of would be a 10 gigabyte 24 port Cisco switch, which is priced around $2,000 to $3,000. The gateway I would want to use is a PF Sense box, and what the PF Sense box does is it is used to make a dedicated firewall router for a network, and it's a really unique box. It contains, of course, PF Sense, and with the physical server of this, a physical firewall, it just adds another layer of protection instead of just having another network firewall. The PF Sense box I thought would be good for the lab would be an XG-15411U PF Sense Security Gateway Appliance, and it costs around $7,592. It's a little expensive, but it has too many pluses to it for a lab like this, for a campus that is, you just should be able to have it. We should be using something like this with that much security and all of that. After the switch comes the computer hosts, and the idea I had for the computer hosts was to have thin clients, which are stateless hard driveless desktops. What we would do with those, you could beef them up, and then we would have the thin client have a partition that connects to an NFS server that allows the thin client to be able to fetch different OS images, default images, and maybe custom images of what you've made yourself, so you can continue work for the next day. And these default images would be Ubuntu, different Linuxes, different forms of Windows, and all these things where you're able to flash it real quick on a computer that doesn't use a hard drive, so you can do your work, and then at the end of that class or that lab period, you can save your image of what you've done on that work onto an NFS file server, which comes down to the TrueNAS, which is a server that holds the FreeNAS program and ZFS file system. And the way this would work is that this server this TrueNAS server would allow for NFS file sharing, which in this file sharing, this hard drive would contain all of our default images and set up from the ZFS file system into a way where users can go and save their data privately without other users other than administrators being able to access their images. This way you can allow for continued lab work on a project maybe that you can't finish in one day, and this also allows for a cheaper setup. With the thin clients in the TrueNAS, you will be able to possibly get it cheaper. Thin clients are easier to upgrade, adaptability, which is really important. The TrueNAS I was thinking of would be the TrueNAS M50. So the next part of this would be, I guess, more into explaining of how those are connected. What would happen would be that there'd be a PXE server set up on these thin clients, which allows networked computers that are not yet loaded with an operating system to be configured and booted remotely by an administrator. This would allow you to fetch the OSs from the NFS files server to boot to your designated OS using TFTP. So the sequence of events would be: you power on your computer, go into BIOS, then your network card's PXE stack, then the network boot program downloaded using the TFTP from the TrueNAS server to the client's RAM, and that way you'd be able to quickly flash these images onto these thin clients to allow for easy access and allow for maintaining a lab that is supposed to be highly adaptable but still usable. you don't want to have to buy numerous more computers and hard drives after years, it would just get too expensive. So with that in mind, the next part in the network setup would be the ESXi servers. These ESXi servers are servers that are used for deploying and serving virtual computers. A program that you could put on one of these ESXi servers would be vSphere Essentials for like a starter kit. For academics, it's less extensive. It costs $336 with the academic pricing, or vSphere Essential Plus, which is more expensive with an academic pricing of $3,263. I would probably go with the Essentials Plus because it has more tools and it has more expert level settings that you could set up to allow for the most customization from these for these virtual machines. There would be VMware vCenter server also installed on the ESXi server, which allows for the centralized management of these virtual machines that the ESXi hosts centrally with the vSphere client. So this vCenter this vSphere would work together so you could deploy, maintain, and keep up these virtual machines onto multiple computers without students having to download their own licenses of VMware and all of these other things. The center server does get pricey. It has a price of a 3-year service for $9,599, but it might be possible to ask VMware or inquire with VMware about an academic pricing for a university, maybe send an email, contact them somehow. They didn't have an academic price lined up on their, or showing up on their site for the vCenter, but I'm sure that's something they could work with with. Of course, another thing that should be connected to the main network or the gateway network would be of a Wi-Fi router, to a highly protected one. I had one in mind, which would be a Asus ROG Rapture GT-AC5300 router, which allows for 8 WLAN ports. The security includes WEP, WPA, WPA2, WPS, WPA2 Enterprise, Radius Server, and it has parental controls. The router costs $430, but it's well worth it because this router would be used for just cybersecurity lab students to connect their personal devices, possibly phones that they want to try hacking their own phone or something with a program or something like that. That way they can have it connected to the gateway network and not having to connect to the main SUNY Canton network while in this isolated lab. So I went over the purpose of the gateway and the purpose of the switch already. But I just want to clarify that with this gateway, it would be a great addition to have a physical firewall to help insulate the lab network. That way, kids aren't getting on to our gateway network, and our lab activities aren't interfering with the main SUNY Canton network, and that goes along with the switch, allowing these devices to connect together and network together to be and send data to the gateway and whatnot. The ESXi server with the VMware vCenter server and the vSphere Essentials Plus, that would be the physical sort of side of the network for the virtual lab. The ESXi server and these programs should be installed to allow for fast and well-maintained network VMware distribution. So getting on to how we would flash all these thin clients that are connected to this server. So what we would use is, my idea would be to use Clonezilla, which it's a program that copies disks and disk imaging, data recovery, and deployment of images for operating systems. What we could use that to save flashed OSs and data to reflash host computers with ease. This goes along with the default OSs that we could pack certain programs into, then save those flashes so we could flash those easily and quickly onto different computers. The way I would set it up personally would be having another external server, the TrueNAS, which I've already mentioned, that would hold and be set up to allow you to fetch, on boot, allow you to fetch these OS flashes and images from this server itself. So nothing is locally hosted except for these servers themselves. I think that'd be a great quick way to do this, cost effective. Basically all these attributes that I said before, it goes along with all of those. The NFS partition on the thin client can be done. I have looked it up. I'm not entirely sure what kind of thin clients we should use. I looked at multiple HP ones. I try to find the best ones available, but I'm never quite sure what the university is willing to put in for money and what we're willing to get rid of for performance to make it more cost effective. But thin clients are decently cheap and powerful, which would allow for a pretty good system to deploy these activities on. A specific OS image that I want to mention that would be really useful to flash would be the Kali Linux, or Backtrack as it used to be called, OS. This OS is specifically made for cybersecurity tasks, and it's loaded and pre-installed with 600 different tools. These include tools for information gathering, vulnerability analysis, wireless attacks, web applications, exploitation tools, stress testing, forensic tools, sniffing and spoofing, password attacks, maintaining access, reverse engineering, reporting tools, and hardware hacking. All of these tools are pretty essential and are usually probably loaded onto these other OSs, these other default OSs. A lot of these tools would probably be using both, but Kali allows all of these to be packaged in one simple, smooth, small operating system. It's very easy to use. I've looked at it myself, and I would tell you I'm a big fan of it. It's just a really good system. Maybe shouldn't be a default, but a nice OS image to definitely keep in mind to include. So, going along with that, it's time to get down to the virtual server and how that is supposed to be set up. So, the way I had in mind was to set up so you have to set up your, I have it right somewhere here. So you would set up your ESXi server that holds vSphere and vCenter. That is connected to the main switch and the gateway. Then the vCenter server itself needs to be also connected to the switch. It's used to host the virtual network used by the student VMs. And so there's going to be 3 layers of virtual networks we're going to talk about. The first thing first is that the physical server, the main administrative computer with the ESXi server, that connects to the switch itself and the gateway itself. This allows it to be connected to the physical network. The next step in would be the virtual network 1. And this network is set up by the administrative vCenter server, which allows for easy deploying of these virtual machines to student computers, where they can fetch these machines quickly, where they can use them quickly, open them up, and just easier than having everyone go and download VM workstation and pull these up manually. These virtual centers and servers, and all the VMware should be installed on these hosts or default OSs that you can flash. That way you can use a virtual machine for almost any of the OSs that we are able to flash on. The second virtual network that these virtual machines will be connecting to is used to connect the student computers to the virtual network that the vCenter is going to be hosting as a router. So these virtual machines on our virtual network can be connected to the internet. This allows for another virtual firewall to show or to stop the flooding or any of that kind of any of our tasks from interfering with the main physical network or the switch or the gateway or the campus network, any of that stuff. It's going to, all these virtual machines would be connected through the a virtual network that's being run by the vCenter server as a router. The third virtual network is used as a test server to test your task without interfering with the virtual network, or the second virtual network, which that connects the VMs to the internet or the main lab network. So you need this third network set up to allow for a test network to be have tasks used on it. That way your tasks or whatever you're doing doesn't interfere with the rest of the students using that virtual network 2 that is allowing for internet on their own computers. If you were to use the VM or the virtual network 2 to test your attacks or your tasks or anything like that, you would possibly disrupt, or it would disrupt the flow of everyone else working on that VM, their virtual machine that needs that network connection, to the internet and stuff like that, because these virtual machines should not be directly connected to their main network. They're going to be connected to the vCenter's router setup for the virtual network. The virtual network 3 is probably one of the most important networks you have to set up. It's supposed to be an quote-unquote external server or machine, but it's basically, you can set up in any way you really want it, just to allow for your tasks at hand to be performed on that, rather than the virtual network 2, allowing everyone to connect to the internet, or our main gateway to internet, or even the SUNY campus network. A few external hard drives or programs that I think should be installed or utilized in the lab. I have a few of them. First of all, I believe that we should each either buy our own USB keys or be given one for a semester or so for the lab that contains Clonezilla, gparted, OPHCrack, and Kali Linux itself. Clonezilla and gparted, gparted is a partition editing application used for creating, deleting, resizing, moving, checking, and copying disk partitions in their file systems. I believe Clonezilla and gparted would work well together to make sure everything is working properly, and with these USB keys you can plug them in directly to your computer and not have to worry about something not loading up or partitions failing or something like that, so you can fix it all before you boot into an actual operating system. Another program that should be included in this, or maybe even just on different default OS images, would be OPHCrack, which is a free open source program that cracks window login passwords by using LM hashes through rainbow tables. The program includes the ability to import the hashes from a variety of formats, including dumping directly from the SAM files of Windows. This is just a neat little program that could help show how you could hack a Windows computer. It's just, a little fun. It's something that maybe some students aren't aware that exists, or, don't know how it works, and we can get into the theory of that in class by using this program, possibly. It's just something that's nice to have around. Another device would be the Proxmark 3 RDV4, which is used for RFID hacking. Can read about any RFID tag, pretend to be a reader or a tag itself, sniff the communications between a reader and a tag, and operate in a standalone mode without a PC, but it still has to be plugged into a power source like a a little USB power block or something. These are priced around $300. It would be neat to have a couple of those in class for just another tool just in case we need to do something with hacking RFIDs. A Bash Bunny, which is a multi-function USB attack and automation platform for penetration testers and system administrators. It's used for quote-unquote bad USB demonstrations, like USBs uses keyboards to execute commands on a victim's computer. A couple of these could be fun to have around or useful to have around to learn about how they work and stuff like that. They are priced at $95 to $99. Another neat little tool that we could get for the lab would be a Packet Squirrel, which is an Ethernet multi-tool designed to give you covert remote access, quote-unquote painless packet captures and secure VPN connections with the flip of a switch. It basically just intercepts packets on a LAN. They're priced at $59.99. Again, having just a few of these, it's not too expensive with the budget, and it could just be another little tool that we learn about and try to figure out ways to prevent something like that. I have a few programs too. One program that I believe should be on every default OS, or at least a majority of them, is Low Orbit Ion Cannon, which is just used for stress testing and DOS attacks. It's just a neat little GUI program that allows for these kind of attacks easily, that we could try stress testing on these virtual networks possibly with it or something like that. Just another neat little program to have around. Havij, which is a Iranian SQL injection program. It has a GUI. It's pretty easy to use, and it can teach you about how SQL databases are set up, the queries, the tables, the columns, and all of these things. I've used this personally to test on websites that allow you to test on them, legally and stuff like that, or posted online purposefully. It's a real easy program to use. I've gotten pretty much most of it down. It's just a really fun thing to use, I think, and would be nice to have in the class just for data, SQL query databases and stuff like that. I believe I have a few other things that I want to add. I mentioned Clonezilla before, but that's just another program that should be on every computer. I think that might be it actually for the different programs I think should be used. Like I said, Kali. If you're looking for a list of tools, Kali has a tool list online that has an extensive list of all their tools, and I would list some of those tools onto here for other OSs, but I believe that if we needed to, we could just look at the list of Kali's tools and see if we need to use one of those. There's just so many tools covered on that it's really hard to keep mentioning some. Lastly, I have the lab policies. I've came up with a few that are either edits or new policies because of this lab. First is the lab is only to be used by students with majors approved by the information technology department heads and the university president, meaning students cannot go into the lab or use the lab unless they have permission from the department heads and the university president if their major fits for that lab. Another policy is the lab is to remain locked from the outside unless a professor is in the lab. To use the lab when it's unoccupied, you must schedule a date with a professor who can unlock the door and give you written permission with a signature allowing you to use the lab. You're responsible for any damage potentially done in the lab while unaccompanied, and your use for the lab unaccompanied can be permanently revoked if you misuse the lab or allow an unauthorized student into the lab. Basically, this allows for students to use or continuously go to the lab and use the lab to work on projects that they haven't finished in their classes or something like that, but it still requires you to have permission from a professor with signatures showing, with a sign-in sheet, sign-out sheet showing when you're in, when you're out, and covering the fact that you are responsible for any damage that is caused in that lab while you're by yourself. Um, Another policy I came up with was the lab equipment is to only be used for permissible hacking, meaning you must get permission from an instructor to hack something or permission from a fellow student if you are trying to hack something of theirs. Basically, don't hack something that is not yours, you don't own, don't have permission to hack. It's a simple rule, and that could go a long way. No lab equipment is to be taken out of the lab without written permission. You must also sign a sheet specifying what you borrowed along with the professor's signature on the sign-out sheet. If you borrowed something from the lab, it's only to be used for educational, non-nefarious use. If you are found to be using equipment nefariously, you may get banned from borrowing equipment, banned from the lab, and or removed from your program. You are financially responsible for any borrowed equipment. I believe that you should be able to borrow certain equipment, of course with all these parameters to it. That way you can test these things out on your own home computers, your own networks, whatnot, just if you use it in any way that's that's against the rules already, no using it on the SUNY Canton network, any of these tools, no using it on people who do not give you permission, but maybe you want to try one of these tools on your own computer or your own device to test how this works and really get a feel for what's going on. There would be restrictions, maybe not the more expensive items could not be taken out, but things like the Bash Bunny and stuff like that could be taken out, they're cheaper, but you'll still be financially responsible if something were to happen to it. And depending on what would happen, the university would have the right to waive that fee or not. Another policy I came up with was the gateway is a layer of protection, keeping the cybersecurity lab isolated from the main network. It is not to be hacked or attempted to be hacked. Doing so will be treated like you are trying to hack the SUNY Canton network, meaning you could face multiple disciplinary actions along with possible legal actions. This gateway is to be treated like any other SUNY Canton network or device. This is a nice policy to ensure that students know that they are not to mess with the gateway, because that is the biggest firewall, the biggest insulator of this lab, and without that gateway we wouldn't be able to perform most of these tasks. So this gateway is really important. It's also expensive, and it hosts all these devices, these networks. It is something that I believe if you were to mess with, you should have disciplinary actions taken on to you as if you were messing with the main SUNY Canton network. And my last policy that I came up with is that the program's computers and lab itself comes from the generosity of the university. Any attempt to use these tools for purposes beyond your given assignment or permissible task is prohibited. Doing so can result in your removal of the program, ban from the lab, or being kicked from SUNY Canton. This means if you use any of these tools that the SUNY Canton has generously given to us and paid for any purposes other than what the instructors have told us we can do or what we're supposed to do, then you have the chance of being removed from the program, banned from the lab, or even kicked from SUNY Canton. This includes things like using the programs while in class or in the lab to try to hack through to the SUNY Canton network itself, or using these programs and tools to hack your friends' devices or anything like that. This gives a basic large bubble coverage to SUNY Canton itself, and the students knowing that if they do something they have multiple consequences they could face. And I know being kicked from SUNY Canton is a big step to take after, but I believe that if you were to use a tool like these, which can be dangerous in certain hands, you should be removed from campus if you are continuously trying to use them or used it for nefarious purposes like information stealing, credit card information, identity theft, any of these illegal actions that you could get arrested for, anything like that. That is why I think you should be kicked from SUNY Canton. So in conclusion, this is the design I would go with personally. It doesn't cover every in and out. There's so much that you could talk about, so much you could go through. I didn't get to cover everything I wanted to cover in this video, but this basic outline theorizes what you're able to do, pricing on certain things, different tools that we could use for different activities. I've gone through quite a few different types of tools that maybe someone hasn't heard of yet to try activities that maybe people don't even know exist, like NFID hacking or something like that. Thank you, and have a good day.